The following video demonstration walks through the process of deploying a highly available application delivery infrastructure on top of Equinix Metal using F5's BIG-IP platform. My demo environment consists of two F5 BIG-IP VEs deployed on the Kvm hypervisor and provide layer 4 through 7 traffic management and security services and are configured in an active-passive mode, though active-active and additional active BIG-IP instances can be deployed as needed. Two Nginx web servers are deployed and are defined as pool members on the BIG-IPs. The Equinix Metal routers are the gateway to the Equinix Metal environment and also redistribute the virtual server IP addresses advertised by the BIG-IPs using BGP. I'm doing a multi-NIC BIG-IP deployment, and I'll need to create VLANs for the management, external, internal, and HA interfaces. Next, I'll need to request 3 elastic IP address blocks, one for each BIG-IP management interface, and the third for the virtual server IP addresses that will be advertised out via BGP. Before I can use BGP in the Equinix Metal environment, I first need to enable it at the project level. At this point, I'm ready to deploy the 2 Ubuntu servers that will host the Kvm hypervisor that the 2 BIG-IP instances will be deployed on. For my deployment, I've chosen the Dallas location, but there are many other Equinix Metal locations around the world. I've selected the C3 small x86 instance size as that more than meets my needs, and I've chosen Ubuntu as the host operating system. While not required, the user data section provides cloud init functionality, and I'm populating it with some packages to install and configuration files to write, and am now ready to deploy 2 on-demand servers. In real time, the server deployment process takes about 5 minutes for the servers to be ready to configure, but for the purposes of this demo, I've sped up the process. In the video, I'm going to step through the process of configuring one of the servers, but with the exception of IP addresses, the configuration of the second server is identical. When an Equinix Metal server is first spun up, it has 2 network interfaces that are connected to 2 different switches and supports layer 3. For my deployment, I need several layer 2 VLANs and will need to convert the Equinix Metal server network to hybrid bonded mode, which provides both layer 2 and layer 3 while still being connected to 2 different switches. As part of the network conversion process, I need to select the first VLAN to attach. However, I will be attaching the 3 remaining VLANs in the next step. Once the conversion to hybrid bonded mode is complete, I can now attach the 3 remaining VLANs in one step. Next, I need to assign one of the elastic IP address blocks that I requested in an earlier step, and we'll be using that for the BIG-IP management IP address. I've already enabled BGP at the project level, but I also need to enable it at the server level. I'm now ready to connect to the Ubuntu server and begin configuring it. I'm using KVM as the hypervisor and have chosen to use bridge networking, although there are other networking options available. Because I'm using bridge networking, I'll need to configure the bridge interfaces and IP addresses, and I have a configuration file that I will be appending to the existing network interfaces file. I've restarted networking and can see that the bridge interfaces and IP addresses are now configured. Due to the architecture of the Equinix Metal environment and the fact that the BIG-IPs will be deployed on the KVM hypervisor, I am unable to establish BGP neighbor connectivity with the Equinix Metal routers directly from the BIG-IPs. However, I can establish BGP connectivity with Equinix Metal routers from the Ubuntu servers using the open source BIRD routing package. In a later step, I'll be configuring BGP on the BIG-IP to establish BGP neighbor connectivity with the BIRD engine on Ubuntu, and I'm essentially using it as an intermediary to overcome the limitations of the Equinix Metal environment. Equinix provides a set of convenient scripts and application that can be used to perform the initial configuration of the BIRD routing engine, and I'm going to clone the repo to get the application and scripts. With the initial BIRD setup complete, I'll need to modify the configuration file and add the BIG-IP external self IP address as a new BGP neighbor. Finished with all the prep steps, I'm ready to begin the process of deploying a BIG-IP instance on KVM. There are several ways to spin up a Kvm Guest, and I'm using the virt install utility to do so, and I've allocated 16 gigabytes of RAM and 8 vCPUs. Next, I'm going to start the BIG-IP Guest and also configure it to automatically start when the Ubuntu server is rebooted. After giving the BIG-IP a few minutes to boot up, I'll need to connect to the BIG-IP via the KVM console and set the BIG-IP management address and route. Each KVM Guest has a unique numeric ID, and I'll use the verse list command to get the ID of the BIG-IP Guest. Using the numeric ID of 3 returned by the verse list command, I'll connect to the BIG-IP using the verse console command. Now that I've connected to the BIG-IP, I'll change the default root password and also configure the management and gateway using the IP addresses from one of the elastic IP address blocks allocated in a previous step. Using the console can be clumsy, and because of this, I'm going to establish a regular SSH session with the BIG-IP. At this point, configuring this BIG-IP is the same as configuring any other BIG-IP, and I'm going to use tm shell commands to complete the BIG-IP configuration process. With the setup complete, this BIG-IP is active and in standalone mode. While not shown on this video, I've deployed the second BIG-IP in the Equinix Metal environment and have created a DSC cluster using it and the BIG-IP I deployed as part of this demo, and can now see that the two are in sync. From the BIG-IP web UI, I can see that BIG-IP number 1 is in standby mode and BIG-IP number 2 is active. I need to confirm that the deployment was successful, and I'm going to use one of the elastic IPs being advertised out via BGP to see if I can access the web page of the Nginx pool member. In order to test failover, I'm going to force the active BIG-IP to standby. After failover, I can see that what was the active BIG-IP is now in standby mode, and what was the standby BIG-IP is now active. I'm still able to access the Nginx web page, and that tells me that the failover was successful. Thanks for watching my demo video. For more information, please come see us at f5.com.